Yes, ma'am, we can go with model. Ma'am, your voice is too low.
Today you're going to take class or?
Yeah, ma'am. I have prepared PPT of the first 3 topics and 10 slides.
How the PPT with you?
Yes, ma'am. I have it.
Yes. Okay. I will stop sharing. You can start sharing.
Okay, ma'am. So, is my screen visible?
Yeah, it's visible. You can start. Ahmed,
okay.
I think Ahmed not yet joined. Rahul is here.
Now, Ahmed, you will join.
Okay, can you check with Ahmed? Okay, you can start.
Okay. Yeah, today we are going to discuss the introduction to the database management systems. We are the characteristics of database management, database approach is that we have multiple approaches when we are going to design a database, and when we are going to design the database initially. So yeah, first approach is that self-describing nature of the database system. So it is a fundamental characteristics of a database approach to when designing itself, or entire definition or description of the database also should be stored as a metadata in the database again. Like how many tables are there, like what are the fields of a table, and what are the data type of a fields. All this information should be stored as a metadata inside a database. So this approach is known as self-describing nature of a database system. And the data of the data is known as metadata. So that is stored in the database again. So this definition again will be stored as within a DBMS catalog, which contains information like a structure of every file, the sorting order, the storage format. Basically, all the technical details of a table will be, or the constraints will be stored in this particular catalog, DBMS catalog. So yeah, the knowledge stored within this particular catalog is called as metadata. So it's a data of the definition of a data, and it describes the structure of the database. The catalog is employed by a DBMS software. There will be different DBMS software like Oracle or other DBMS software, which will hold this particular metadata inside the database table, which can be used by database administrators or to know the database structure, how it is being designed, and things like that. So yeah, then the approach of the database approach is that isolation between the programs, data, abstractions, and data programs and data abstractions basically. So in all the data and the program, we write application programs like codes and things. Also, there will be data which the application program will receive from the user and for processing and all. Both the programs and data should not be stored in the same place. It should be having some isolation between them. So with like overwriting can happen, or can some conflict, some data like issues can occur. So it can cause inconsistency. So keeping the programs and data update is very important. So that is the second approach. So we try to segregate, keep separate program and data independence. We try to provide. So that is what we do it in an approach to do this isolation between the programs and data, and that is called as program data independence. and data abstraction. So, and we have approach 3. The approach 3 is a support for multiple views of a data. So a view is nothing but it will table is the structure or something which will hold the data, but a view is just a front end which will again request backend database for the data. Actually, view is just a plain structure. So we can if we have 2-3 tables, we can create multiple types of views with mismatch combinations and mixed match combinations based upon the requirement of the user. So each user will not be the same. There will be a admin users, there will be a transactional users, and there will be a like analytical users and things like that. So all of them require different types of data, but the data will be stored in a similar type of database. So views can be modeled according to the end user requirement and can have different types of views for same database. So which can provide a required data. For me, more details is required as a admin. Like for a transaction user, only limited details will be required. But for analytical user, the aggregated results will be required. So different views will be modeled according to the end user requirement or end application requirement, and that will be given to them. But backend databases will be again the same. The each views will be again requesting the backend databases for the data as per required. So that is the approach 3. Then the approach 4 of the database approach is that sharing the knowledge and multi-user transaction processing. So multi-user DBMS system, as the name implies, right, a single database system can be accessed by multiple users in a given time, but it should be working consistently and concurrently. Concurrent with one system must be accessible by multiple users, and it should be consistent. There should not be any inconsistency. If I'm trying to read some record and other person is trying to update the same record, and the data which I'm going to read is invalidated, so I have to be that like some locking mechanisms and things like should be followed. That is the atomic principle of the database modeling. So all these details should be taken into consideration whenever we are going to do a database design. So and yeah, there are sort of applications like OLAP, OLTP, the online transaction processing application, online article processing application. The fundamental rule of multi-user DBMS software is that to make the concurrent transactions operate correctly and efficiently with no inconsistency, as I said. So if you take any up layer like flight booking or like ticket booking system, so a same seat should not be allocated to both multiple users at a time. If one seat I'm trying to book, that seat should be showed as blocked or something for the other user. For the time of that thing, I think I make a payment or something and I block the seat permanently. That should be showed as it is blocked by other user. It should not allow such kind of mistakes as such when it is a concurrent system. So that should be taken care. That is the approach 4. So then next, talking about the if we follow the database approaches, then what are the advantages that we get, right? So the first advantage is that we can control redundancy. Redundancy is storing the same data multiple times actually in multiple different tables. So that can be eliminated. And for that, first we have to analyze what are the tables that require, what are the relationship between the tables that needs to be established and things like that. So, and the second, it will avoid the storage space. If there is a redundant data, there is more storage being used. If there is more storage being used, then we have to purchase or pay for more database servers and things. So if we are reducing the redundancy, then storage space is also reduced and things will become smaller. So the files that represent the same data may become inconsistent. Like if we have multiple data redundancy, like you're trying to update in one database table, that's the data record, and other database tables are not updated. If the person is reading or application is referring to the other database table which is not updated, is reading a data which is old or invalid data. So it becomes inconsistency in that way. Redundant data will have multiple problems in this area. So controlling redundancy is very much important. So a few other advantages are like we can restrict authorization. We can authorize person and then provide access to database systems. So like for example, the login databases and all will have the login ID, passwords and details and things like that. We can't give access for all the users or any applications directly. So it becomes very much necessary for authorizing a person or an application before giving access to that particular database systems. So providing persistent storage for program objects, providing storage structures and search techniques. So few DBMS software provides searching techniques and searching algorithms comes built in, so which will help for searching the data very much easily with efficient query processing. So providing backup and recovery. So we have, when we design a database management system, we also plan for backup and recovery in the like DR sites and disaster recovery management and things like that. So that also needs to be considered. So multiple user interfaces. So there can be multiple views or multiple applications, but if you're referring to the same database management system. So a DBMS software or a DBMS system should be capable of supporting multiple user interfaces and getting and giving the data back to them. So also it should be capable of representing a complex data structure. There can be a complex data structure like addresses. Like address can be one field. Inside address there will be a street, a street, door number, cross, main, and the landmark and things like that. A structure can be a complex data structures. Like those kind of complex relations or complex data structures also should be supported in a DBMS system. And to also it enforces the integrity constraints. So integrity constraints, like there will be multiple tables, means that the second table is dependent on employee ID. Then there is a, if we assume there is a table like master table for employee IDs, and there is another table like salary table. The employee ID in the salary table should be belonging in the table one. Without the employee ID without being an employee, you can't receive a salary. So those kind of employee ID or the key integrity constraints should also be taken care and should be maintained at all the time to maintain the consistency of the systems. And also permitting, influencing, and accessing using the rules. So based on some rules and authorizations, or providing rules and things like that, we can control access to the database systems. So then actors on the scene. If we take one system, there will be multiple actors, as I said previously. So if you take a database management system, there will be a designer who will design the database system. What he will do, he will gather the requirements from the organization or the end user, and based on that, he will do the database designing using ER diagrams and other tools and things. So he will be designing what are the database that is required, what is the relationship that needs to be established between the each and every database system, so that it can reduce the redundancy and it can improve the performance and consistency, things like that. It will follow all the database approaches that we discussed. So it will follow those accordingly. We will design a database system. Once the database system is designed, then it needs to be managed and provide, like we have to have a security roles, users, authorizations and things like that. Like that will be coming in with administrators. So DBA, database admin, is responsible for authorizing and providing accesses to the particular records and things. So based on his intention is to control them, minimize the security breaches or the poor response time of the system. So system should be up and running all the time, and it should be consistent. It should not have any security breaches as such. So that will be the DBA's responsibility. End users will be like a requesters or the query generators. Like if I'm using one application, if I say if I want to see how many seats are available in a theater or how many seats are available in a train or flight, anything. So I will be an end user. I will be using one application. So that application will in back and send a query to the database and get all the details and show it in the front end screen. So I will be some end user then. So that is the end user who is using the application to get some status report or anything from the database, is basically an end user. Or you will be using a front end UI to request the data, and back end these queries will be created and the database data will be fetched. System analysts or application programmers or like software developers and testers, all the things who develop the applications. For example, as we said, right, end user will be using a front end application like say flight booking system or something. That is an end user application. That application must be designed. That design will be done by the software engineer or system analyst and application programmers. So they will do this design. They will be writing the dynamic queries and things like that. They will take some input from the user. They will dynamically create a query in the backend and populate these values requested by the user in the query and make a call to the backend database. That data retrieved will be again fetched and showed to the user in the screen, in the UI, the user interface. That is what the system analyst and application programmers do. So these are the different types of actors that involved in database management systems. So designers, administrators, the end users who uses the application. The system managers and application programmers are like the developers of the application, the front end or the back end application, to establish a connection or a contact between the end user to the database systems. So history of database applications, if we see early database applications uses hierarchical and network systems. So there was a file type, flat file type and hierarchical systems previously. Then database evolved. So providing then the database abstract database was made available. Then database concept came in. So the providing data abstraction and application flexibility with relation databases. So initially there was only a relation databases like simple databases. With like 2-3 databases, and which will not hold any complex object types or anything. It was very plain database tables. That is a relation table. So then came in the object-oriented applications. Then there was a object-oriented programming language that came in like Java and other things. So when that kind of like Java and things came up, there was a more requirement of storing the complex data types and things like that. So in that point, the relational databases was not capable enough of doing that particular job. So then there was an advancement in database management systems, and what we are learning is now currently the OODBMS and things like that. OODBMS and ORDBMS, all these things coming when the application started demanding for the complex databases and structures. So then the interchanging of the data through web using e-commerce usually happens using XML, using a SOAP API or REST API and things like that. So XML is XML is one of a standard format in language which being used for interchanging the data. So then the database capabilities was later on further extended based on the new applications and new requirement. As on when the years passed during the latest generation, different capabilities was added to the database systems, and there was new advancement that happened. And yeah, so databases and versus information retrieval systems. So yeah, that's it. Hello, ma'am.
Okay, good presentation. Any doubt, Ahmad?
Yes, ma'am.
Naveen, you please share the PPTs to
Yes,
all and send it to my email ID also.
Okay.
Okay, any doubt? Ahmad, when can you take next to 3 topics?
Yes, ma'am.
You are ready with the PPT?
No. I'm not ready. I was busy these days.
Okay. So you take next to 3 topics from the syllabus, first unit, and
Yes.
Rahul, you take remaining 2 topics. Okay.
Okay.
Okay, ma'am.
Okay, we will continue the class on tomorrow. Tomorrow I will schedule one more class. I will take module 4. Today we have a meeting around 2 o'clock regarding conference. Okay. So if you have any doubt, get the doubt clarified from Naveen.
Okay, ma'am.
With the topics.
Yes, ma'am.
Tomorrow can I schedule from 11 to 12 or 12 to 1?
Yes, ma'am.
Yes, ma'am.
Okay, tomorrow I have 9 to 10 another class. Then I will schedule 11 to 12 or 10 to 11:30. Okay, I will send you 1 or 2 hours before.
Okay, ma'am.
Okay. Can we have tomorrow 11 to 12:30?
Yes, ma'am.
Yes, ma'am.
Okay, thank you.
Okay, ma'am.
Yeah, thank you.